So what we're talking about now, though, is weather. Something that affects all of us in ways great and small. Meteorology, that is the scientific study of weather. And of course the question, what is weather? It's got its own definition. Weather is the condition of the atmosphere at any given time in terms of temperature, air pressure, and humidity. So weather affects us all. It affects how we dress, heavy coats versus t-shirts and shorts, affects what we can do. Example, playing hockey versus sunbathing. Affects our economy. I mean, people want to get away from the cold in winter. What do? They go to someplace that's nice and warm. People want to go skiing. They go someplace where there's a lot of snow, a lot of mountains. Again, weather affecting our activities, weather affecting the economy. Sample construction. Weather is an important factor here. You don't have a lot of construction being done usually in the winter months because it's so cold and the weather's usually so bad. But when weather starts getting warmer again, spring, summer, and fall, that's when you have most of your building activity. Yes, in terms of temperature, it's how hot or cold it is. Temperature, that's usually what we mostly want to know is how hot or cold it is. And what kind of weather we get, whether it's fair and sunny or cloudy and rainy, that's often determined by air pressure. Air pressure shifts a little bit according to weather patterns. Humidity, how much moisture there is in the air. It's all very important things. So even though water vapor is actually a very tiny part of the atmosphere, it's a major driver of weather. How much or how little moisture is in the air. Now all this, of course, is different from climate. Climate is the long-term weather pattern in one area. Basically, the average weather. So 1 or 2 years does not make climate. Climate takes into account that yes, there are extremes of weather from one year to the next. But some years, like here in South Arkansas, we may go years without snow. But then all of a sudden, 1 or 2 years in a row of ice during the winter. There are some summers that are hotter than others. There are some winters that are colder than others. This past winter we've had, 2023 to 24, it's actually been a fairly mild winter. And here it is, the end of February, and we've been short sleeves for a long time. We only had maybe 1 or 2 weeks of really cold weather. That's unusual. But 1 or 2 unusual years does not affect the climate. Now you put in 10, 20, 30 years of unusual weather extremes, then it starts affecting the climate. Then it starts affecting the averages. Like say, for example, go up north of the Arctic Circle, which it's a very cold climate. Temperatures almost always near freezing or maybe just above. That is their climate. Here in South Arkansas, mild winters and hot summers. The climate, say, go out further west, New Mexico and Arizona. Warm winters and hot summers, but very dry. But for Arkansas, very, very wet weather. Again, all that kind of forms the climate. And there are different climate patterns and types all over the planet. Now, what's the main driver of the weather? The sun. Solar energy is the source of heat for the Earth, and it drives the Earth's weather. So you have the process called insolation. The amount of solar radiation reaching the surface. Now, several factors affect weather and temperature. The angles of the sun rays and the amount that reach the surface. The amount of water vapor in the air, like we talked about, the humidity. The amount of cloud cover. Whether it's land or water at the surface. Elevation. It's cooler at higher temperatures. It's cooler at higher elevations because differences in air pressure versus at lower elevations. The degree and direction of air movement. All those are factors that affect how much solar radiation is reaching the sun's surface. So now it tends to be a very cloudy day. It's not going to get as warm as it usually would on days where it's sunny, in most cases. Because the clouds block the sun's energy. Elevation, higher elevations, is generally cooler than would be down the surface. Direction of air movement. Notice when this wind's coming from the south, it's generally a warmer wind. And that warmer wind coming in, temperatures start going up. So it's been happening the last few days. Temperatures in the 70s here in February. Why? Southerly winds bring in warmer air. But when you have a cold front coming through from the north, oh, you can feel it. Wind changes from the north, that cold air coming from the north, temperature starts dropping. You can feel it dropping. Again, that's degree and direction of air movement. A lot of it is affected by seasons. Remember, the Earth's axis is tilted at 23.5 degrees. And because of that determines the Earth's seasons. In spring and fall, basically, the Earth is kind of perpendicular to the sun. Both hemispheres are basically kind of even. But as the Earth swings back around towards the sun, in the winter, the northern hemisphere is pointed away from the sun, where the southern hemisphere is. So it's summer in the southern half of the world, but winter in the north. It's the season we're moving out of now. We're moving towards spring, where fairly even, where no side is necessarily pointed towards the sun. It's even. Fall in the south, spring in the north, then swing back around the sun again, a little bit more. When the northern hemisphere, the North Pole, is pointed towards the sun, that's summertime in the northern hemisphere, but winter in the southern hemisphere. So on and so forth. It's been doing that for billions of years. And again, that affects weather because here at this point, got a lot more solar radiation reaching the surface. It's also, the days start getting longer. You may have noticed the past month the days are getting longer again. You may notice where the sun is in the sky at particular times of the day, towards sunset. That's shifting a little bit. That's because round Earth, orbiting the sun, axial tilt, where the sun appears in the sky, shifts from one time of the year to another. And of course, it's because of this axial tilt is why in summertime in the northern hemisphere, the North Pole, it's daylight all day long, 24 hours of sunlight. And even in the extreme higher latitudes, we may only have maybe sunshine all day long, or you may have only a couple hours of night. It's because of these extreme latitudes, because the North Pole is pointed towards the sun. Contrarily, winter, because it's pointed away from the sun, it's dark. Got some areas that are in darkness for weeks, months. A few years ago, they made that really cool vampire movie about vampires, so I'd take advantage of that by going to this little town in Alaska where it's going to be night for 30 days straight because of winter. Yes, I know it's fiction, but it makes for an interesting story. But even then, where the sun may not rise above the horizon, sometimes you still get a little bit of light. Just like several hours of, it's like you see in the morning, sometimes before sunrise, it starts getting kind of light in the east. It'll have that same effect. Kind of light for a while, then it'll get dark again. But the sun never comes up. So insolation, how much is getting through? Seasons. Solstice. That is beginning summer, winter, when the sun's vertical rays are its highest point. And the equinox, when they're equal. Or beginning fall or spring, depending on the hemisphere. Solstice, beginning of winter or summer, again, depending on your hemisphere. Reflection, how much of the sun's energy is bounced back into space. Clouds, sometimes there's some energy that gets through to the surface, but a lot of it is bounced back up. Again, why it doesn't get so warm on some cloudy days. But there are a lot of things that can reflect the sun. For example, some of it is reflected by just scattered in the sky. Again, that scattering is why we have blue skies and red sunsets. 21% by clouds. and 6% by the ground. Ever been in the ocean, or a lake? You see the sun shining on the water. Some of that is being reflected back up into the atmosphere. May even heard how different color roofs sometimes affect your energy bill. Darker roofs tend to absorb more energy, so they get warmer. But lighter colors, they reflect more, sending energy back up. So absorption, that is 32% of what happens to the sun's energy. Reflection, that's 32%. That's 32% of the sun's energy reaching the surface. Absorption, the remaining 68%. What's absorbed by? Dust and molecules, about 15%. Absorbed by clouds, 3%. And by the surface, about half of it is absorbed by the surface. And then you have the process that they call re-radiation. The energy absorbed and released from the surface at night. Basically, how it just kind of cools off. You ever walked out on your patio in summertime just after sunset, barefoot? Notice how it's still warm? That's a form of re-radiation. All that heat, energy that's absorbed during the day, it's being released at night. And this, of course, all leads us to a discussion of the greenhouse effect. This is the trapping of energy by the atmosphere. Now, there are certain kinds of gases that are better at doing this than others. For example, carbon dioxide. It's really good at absorbing the sun's radiation. Now, you got to understand, some kind of greenhouse effect is needed. It is vital for life on Earth to exist with this. Example, the moon. It has no atmosphere. So what happens? The moon is its surface temperature is 200 degrees in the daytime and 180 below at night. Because there's nothing to keep that heat in. There's nothing to moderate it. The Earth's atmosphere does that. And certain gases do this better than others. So they use the example of, a greenhouse. All glass. What happens when the sun shines here? Part of it gets into the greenhouse, part of it reflected. But once this heat energy enters, it's trapped, can't get out. Like a greenhouse. Ever walked into a greenhouse that's very warm? That's why they call it that. The glass is acting as a barrier, preventing the heat energy from escaping. But in the atmosphere, gases like carbon dioxide do that. Again, it's one of several that does it, but it's the most common in the atmosphere. So it gets warmer and warmer. And so what happens if you have more heat energy in the atmosphere? It's like stepping on the accelerator of a car. It speeds the process up. It means more extremes of weather because you got more energy. It's moving faster. And so take, for example, that ice storm. It's like 60 odd degrees one day and then 20 degrees the next. That took a lot of energy to reduce the temperature by 40 degrees. That took a lot of energy to coat this entire region in an inch or two of ice. That took a lot of energy to do that. These huge blizzards you hear about up north, yeah, those are very powerful storms. And see, it's counterintuitive as it seems, because of the greenhouse effect. In some areas, it actually does get colder sometimes. But you have more extremes of weather because you have more energy in the atmosphere. Yes, most areas start getting warmer. And so you have the extremes of weather because of warm weather. More hurricanes, more tornadoes, more thunderstorms, things like that. Again, some necessary for survival because of the process of insulation. It insulates us. Our atmosphere keeps us from freezing to death at night. And again, helps keep the surface getting too hot during the day. Again, the opposite of the moon with no atmosphere. But of course, it's extremes of it. You have too much of anything's not good. Too little of anything can be bad too. For example, the moon with no atmosphere, 200 above in the day, 180 below at night. Venus, where it's completely covered in clouds, it's a runaway greenhouse effect. It's 800. The surface temperature is 800 degrees, enough to melt lead. Because the atmosphere is so thick, the sun's energy gets through, but it can't escape. Very thick atmosphere. Mostly sulfuric acid clouds. And yes, they've had probes land on the surface of Venus. They've taken pictures of Venus. Yeah, it's daytime. It's you can tell there's light getting through from the surface, but not a lot. But what is getting through is trapped by the atmosphere. And that's what they've been talking about here with climate change and the greenhouse effect is what happens when gases like carbon dioxide increase in the atmosphere and start driving the weather systems even faster. What happens when basically you get into a sports car and you floor it? It starts running faster. And so this is what they've been talking about for the last 40 or 50 years. All these projections for global temperature changes and stuff, they've been talking about 40, 50 years. It's happening. Even very subtle changes have been noticed. Talk to some of the old timers, like I did when I was growing up in Dallas, and around here they talk about in the old days how it would snow every winter, how every winter you'd have a white Christmas, always snowing around Christmas time. Hardly ever does that anymore. It's a shift that's taking place just over the course of a lifetime. The thing is, with natural climate cycles, it doesn't change that fast. A change like that takes place over 400 or 500 years, not in 40 or 50 years. Of course, because the weather is so important, people are looking at it all the time. Got weather.gov. This is the National Weather Service. Track weather patterns all over the world, particularly in the United States. They issue forecasts. Weather watches and weather warnings, tornado watches, tornado warnings, everything, those come from the National Weather Service. They're the only ones who can issue that. Weather Channel's a good site, weather.com. And there are a few others. Your local news stations will have that a lot. And of course, the National Hurricane Center. nhc.noaa.gov. got a minute, we'll take a brief look at these and kind of how they track weather systems. Now this is the National Weather Service. Let's come in. Yeah, there we go. National Weather Service, weather.gov. And you can see, as far as weather patterns go, it's kind of quiet today. You see on the surface here is some gale warnings here on the coast. There's some wind warnings. Some wind warnings here in South Texas. Up here in Montana, you have, what is that? That is it's a high wind advisory. They get a lot of strong winds coming in off the mountains there, especially on the coast. Like I say, these ocean warnings, these are necessary to help not only aviation, but especially people out on boats. Small fishing boats, small pleasure craft, or even ocean liners and tankers. Dense fog advisory here in the northern half of Lake Michigan, off the coast of Wisconsin and Michigan up here towards the Upper Peninsula. And a little bit here in Northern California. So again, there's not a lot going on right now. But a lot of times you'll have all these different types here. Flood watches, rip current statements on the coasts, flood advisories, flood warnings, blizzard warnings, and so forth. Right now, really not a lot going on. National forecast maps. There's L's and H's. We'll be coming back to this also, but this is the actual map pattern of the expected weather that's supposed to happen. This is forecast for weather bound from 7 a.m. today until 7 a.m. tomorrow. You have a stationary front. Basically, it's not really going anywhere. It's blocking two air masses. What's happening behind it, though, is you've got a lot of warm, moist Gulf air coming in, and ocean air coming in, creating chances of thunder showers here. It's made it kind of a cloudy day, cloudy morning outside here, but chances of showers here. Because it's cooler up here in New York and New England, chance of some ice mixing in that. Cooler elevations up here in Colorado, the Rocky Mountains, chance of some snow. But all these forecast maps are showing what the patterns are doing, what these air mass patterns are doing. Here also temperature variations, what the temperatures can do. Generally fairly warm, unseasonably warm for most of the south and across into Texas and even up to the lower plain states. Cool in the mountains, kind of mild, moderate for this time of year in New York and New England. And all these forecasts people are getting on the news and weather warnings and everything, getting from right here, National Weather Service. Because the government believes that because this affects so many people, because you're talking about people's lives at stake, not just livelihoods, but lives. This information needs to be free. Get to that too. Yeah, hurricane warnings. This is the National Hurricane Center. The hurricane season in the Atlantic does not usually start to the beginning of June. It's about June 1st till the beginning of November. What ends up happening, though, is what do they watch for hurricane warnings, especially late spring, early summer? They watch this area right here, the west coast of Africa. Because these storms coming off the coast of Africa, out of the rainforest, they mix with this warm ocean air, and they start forming these storms that come all the way across the Atlantic Ocean. So yes, the weather in Africa, it affects the weather in North America. And these storms, they will spiral off into the Atlantic. Most of them don't reach the surface, but they'll go all the way back here, curling back towards Ireland and Scotland. Getting to later fall months, most of the hurricanes end up forming here in the Caribbean and the Gulf of Mexico, moving northward towards Louisiana, Florida, and Texas. But because it's still winter time, the waters are kind of cool, so the atmospheric elements aren't there to form hurricanes. And this is the graphical outlook. This is the graphical tropical weather outlook. Look at the satellite image. This is an infrared satellite here, it shows water vapor patterns and so forth. You have some disturbance of storms here off the coast of Africa right now, but nothing that's going to form a hurricane, because the patterns just aren't right. There's got a lot of heavy storms here across the mid-Atlantic, just regular old thunderstorms, and they're just gradually moving along here. Now, it's just kind of cloudy days here across the south. Go to the eastern Pacific. Some heavy storms, but no hurricanes. And this little patterns just kind of spiral off this way. Same thing here. No new tropical cyclones expected during the next 7 days. Go to the central Pacific. Hawaii. Now they're all by itself. Stream in here, see part of California. But they'll track these different weather patterns so they think something's forming versus a less than a 40% chance, moderate chance, 40-60%, greater than 60%. Different kinds, tropical depressions, tropical storms, hurricanes, and what's left of it afterward. And of course, this is their written forecast. No tropical cyclones expected in the next 7 days. Weather outlooks will be issued as conditions warrant, signed by the meteorologist works with them. Yeah, meteorologists don't just work for TV and radio stations. They work for the National Weather Service, and they work for airlines and all sorts of other people. Of course, Weather Channel here, got to have all the ads in it, but it's looking at it right now. El Dorado, 67 degrees. Expected high 74. Humidity, 70%. A kind of moist morning. Kind of cloudy. Air pressure dropping. That means is indicating there could be some change coming in. Visibility, fairly clear. A lot of disturbance. Wind from southerly directions, moving about 12 miles an hour. Dew point. That's the temperature at which a combination of humidity, air pressure, and temperature, when water starts turning from a gas back to a liquid. Dew point. That's what it's expected to do today. 15% chance of rain today, scattered showers. The radar map. Let me show you way out where everything is. Nearest rain to us today is in northern Kentucky and western Kentucky and portions of western Tennessee. This is all taken from different radar images, all put to get pasted together by computer. It shows you the pattern here that's going on. Yeah, not a pleasant day in Louisville, Kentucky. Kind of what's expected to happen over the day. It's a very strong storm expected to form in southern Illinois and southern Indiana. But that's the radar. That's used as a diagnostic tool, also as a forecast tool. Also, you can see where it is, where it's going, and from that you can figure out, oh, what's your forecast going to be? What's going to happen? not just what's going to happen here, but when the storm system's expected to come in. And now with new computer technology, we can come up with a couple scenarios to determine what's the weather going to be this afternoon before anything's formed yet. They're able to tell, yeah, around 3 o'clock, conditions are going to allow for this long line of storms here to start forming. Like I say, that's something that people are going to have to be aware of around the time they pick up their kids in southeastern Missouri and southern Illinois and southern Indiana. They could be some pretty strong storms around there. And another round of very strong storms coming in around rush hour in Louisville and Cincinnati. So they got to plan for that accordingly. And weather forecast getting a lot better. Get to where you can have a 10-day forecast pretty well. But you got to remember, forecast is just a guess. But it's an educated guess. They aren't just pulling numbers out of hats. But you got a lot of different factors going into the weather. So you have to remember that, like our 10-day forecast here, Thursday, March 7th, 39% chance of showers, high 70. That's the best guess right now, but there's a lot of different things that can come in and change that forecast. This is the most probable outcome they're saying from the information they have, but other things can change. Other weather patterns can form in the meantime, which can affect this long-range forecast. And a lot of it does come down to timing. Sometimes the difference of an hour or two in a forecast can make a difference between ice and a sunny day. So it all really kind of comes down to timing. But forecasts are generally a lot better than they used to be. Well, they still get some things wrong, but that's just because new information entered in that they weren't able to take account of. Timing, motion of air pressure systems and air currents and humidity, formation of storms. All just, if it comes around just right the way they're thinking, this is what the forecast will be. 80 degrees by the beginning of next week. And yeah, 42%, 48% chance of rain here and there the following week. Yeah, it's next couple of days not expecting much, but get up to 42% means they're starting to feel pretty good. Basically, they start saying 30% chance of rain, 40% chance of rain, bring an umbrella. Doesn't mean it will, but it means it could be a good chance that there will be. Again, just depending on the timing and how everything all winds up. That's Weather Channel. Okay. Well, there is so much on weather here, but we're going to talk more about that next time. We'll talk about the structure of the atmosphere and more weather terms and the Coriolis effect, kind of how all these weather systems form and move and affect us. So that's our next lecture, chapter 4. So that's that.